So this video, I guess, is what? Shout out to Ava. Shout out to Gunner. Is Colin actually here?
Yeah.
So keep waiting for Colin. I just wanted to get going. So to show you guys something that is changing, and hopefully we can continue on with this. We tried this a little bit earlier in the year. I'm gonna start posting all the answer key information from the lesson and the homework. Lesson, primarily so if we don't get to something and you're still curious about it, you can go and find out some more information about that. Answers to the homework, obviously, so you can check if you actually know what you're doing, or if you have that whole, did I do that right? Then you can get some verification and some confidence. So, notice, please complete the work before you check your answers, and you will have to hit see more. You're like, I already hit it. But so here's your homework answers, all right here. So obviously, like, I don't care to see the answers. Like, obviously, you should put the answer in your homework, but that's not what I care about. What I care about is you understanding the process, right? That's what you should care about too. So if you are like, oh, great, I don't have to do my homework, I'll just go copy the answers. Sweet, sell yourself short, fail the class, that's your choice. Or hold yourself accountable to do the work like you know you should, then use it as a check, as a reference. So Colin, we're just going over the fact that I am now going to be posting answers to the lesson and homeworks. Please do the homework before you go on here and check your answers. I would ask that you do check your answers at some point. So not that you have to do it every day, not that you have to check your answers every day, but that at some point you check your work and verify that what you're doing is correct. On that note, are there any questions from yesterday's homework? Like the first section of 711?
But I just have a question.
Yeah, Jen.
What's that maybe 7.1?
Depends how far we get today. We might start 712. I don't know. And for Ava or anyone else playing at home, here's homework today. We started 711 Monday. We are finishing it today. Talking about polygons.
There was one question of the homework that I was a little iffy about. Number 721.
That's not in your homework yet.
Oh, okay. Well, I thought it was supposed to be due today.
No!
I thought that's what I had listed for the homework.
Well, I said day 2.
Okay. Well, then never mind.
So, I put both on Monday. The reason 712 is like diagonal over there is you might get to starting it today. If you feel like starting it, go ahead. But really, it probably won't technically be the homework till tomorrow.
Okay.
It's not like I'm checking your homework this week. I might get a homework check next week. Alright, let's go here. And pull out your notes. We can probably just continue on from where we were on Monday.
Good afternoon, Nathan Hayhurst. Please come to the office. Nathan Hayhurst, please come to the office. Thank you.
And we were talking about proofreading. So, quadrilateral, we all should know, means what? 4 sides. Now what? So if we back up from quadrilateral, if I don't care about how many sides something has, what do we call it? Could have 3 or 4 or 5 or 6 sides. Polygon. Now what would actually be the definition of a polygon? Colin?
I'd say any complete shape.
Close. Need a bit more details. Yeah.
Any closed shape with straight lines.
Closed shape composed of all straight lines. So, MNOP, is it a polygon?
Yep.
Yep. Specifically, a quadrilateral. We just want to remind us on what a polygon is technically. So, semicircle, is it a polygon?
No.
Circle, polygon?
No.
Technically not. So that's our one-sided or infinitely many-sided, not a polygon, because we can't talk about how many sides it has. So, examine our quadrilateral up the right with the 2 consecutive right angles. What's true about MN and OP, or PO? Write a conjecture about what this is based off those 2 consecutive right angles, and then prove it. I would encourage you to work with partners, but as some of you have chosen to sit alone, that is slightly more difficult. I'm going to go make sure 7th grade gets to work. So I'm going to give you guys some time.
We're good.
Okay, I would do the 2 with the 3. That's working out.
Stop.
Okay,
Get your freaking leg off me.
MNOP is a
We should leave. I don't care. You put that away right now. All right, team. So,
Good afternoon, Naya Dunn. Please stop at the office. Naya Dunn, please stop at the office. Thank you.
Hey, AJ. Hey, AJ. Here for a second.
So you're gonna do that image now.
oh, wait, yeah,
Okay, so when you're walking around, why do you do it on purpose? Because you can plan and totally mess up some of the charges or pinch cables or like be aware of things around you. Sometimes it's all over the place with your body. And it'll affect school property. That's no good.
So now you
What kind of shape is this?
quadrilateral.
Okay, what do we know about MN and OP?
They're
They're parallel, right? Because two right angles connected by the same transversal, MN and OP are parallel. Now, those of you city kids probably are not as used to this as us country folk, but if you have a raccoon or anything else eating your garden or trash or something else, you might set an animal trap. And the animal, no, right, pretty animal, comes in here and the door swings shut after them and the trap would, yes, my art skills are fantastic, the door would be held up like this and it would swing shut.
Is that supposed to be a person or an animal? Alien.
Quit judging me.
You are judgy.
So, here's what I encourage you. The reason I bring that up, and I knew I was going to be judged. When we think of the shape trapezoids, what are we looking for? Well,
One set of parallel sides. A quadrilateral with one set of parallel sides.
I couldn't quite hear what you said, whether you said one shape or one set, but yes, a quadrilateral with one set of parallel sides. Now, if you just say a shape with a set of parallel sides, I can draw you one of those that's not a quadrilateral, or that is not a trapezoid.
You can draw an octagon.
Yeah, hexagon, octagon, nonagon,
Pentagon.
any of those even-sided could, if they're regular, have parallel sides. So I just bring that up to get you to think about an animal trap, and that this actually does kind of look like a trap. Now, this having those right angles makes it special, and D goes ahead and tells you it is a right trapezoid. So then it asks the funny question, are all quadrilaterals with two right angles right trapezoids? So we know that a trapezoid, so hold on, think this through. We know that a trapezoid is quadrilateral, right, one set of parallel sides. If it has two sets of parallel sides, is it still a trapezoid? Is a square still a rectangle? A rectangle is not necessarily a square.
All squares are rectangles, not all rectangles are squares.
So what we're asking then, are all quadrilaterals with two right angles right trapezoids? Discuss it with your partner for me. What do you think? just what it says. Are all quadrilaterals with two right angles? Does it say with only? It doesn't say only, it says with.
It's a double right angle. It's a double right triangle.
So we have this.
What do you think, Topple? You seem very excited about this.
From what I've been thinking about, I think that it would be a quadrilateral because I don't think there's any way to have it not be parallel with two right angles.
Now you're making an assumption.
I've tested it. There's only like one other thing that I would think of, which would be put the right angles at the other opposite sides.
Yeah, but then you can't connect it.
What do we notice about the right angles that we have up here?
They're even.
Yeah. They're consecutive, right, beside each other, or adjacent. I mean, we could say adjacent. Those angles are not. We can't really say adjacent. I mean, you kind of could, but adjacent should be sharing a side. They kind of are, but the angles aren't next to each other. They would need to share a vertex. So instead of saying adjacent, because they're kind of near each other, we say consecutive, right? The one follows the other. We have M and then P, or P and then M. Could I make a quadrilateral with two right angles that aren't consecutive? Because if you want to answer this question, ask some counter questions. Your hand keeps going up and then down. Yeah? Yeah, but that still has the consecutive right angles. Right? Because that would still have... Chris?
I don't think it's possible because if you have one right angle and then another right angle on the other side, then they couldn't be a...
Have this. So there's only one way to connect them.
Yeah.
I'm going to give you 60 seconds. I'm going to give you 60 seconds to draw a shape with a quadrilateral with non-consecutive right angles. If you can't, you can't, but I'm going to give you 60 seconds to try.
Wait, does it have to have right angles?
Has to have two right angles, non-consecutive.
And they can't be what?
That wasn't word.
What are you doing?
So this angle cannot be right, and this angle cannot be right.
Yeah, no, that's not possible.
Yeah, it's not possible.
Not possible.
The only way that you can do it is make a square and rectangle.
What if you have a curved line?
Then it's not a quadrilateral.
It's not a line, it's curved.
20 seconds.
Well,
What if the curve is just a curved line? It's not.
Yes.
That is my initial.
And time. Anybody got it?
Yes.
Colin? What kind of shape could it be?
Come up and draw it.
Do you know what kind of shape it is? That's really the question.
Yeah.
What is it?
It can be a kite.
Let it sink in for a second. Think in your own brain. How could a kite satisfy these circumstances? Yep. What does a kite have to have? Kite, and don't use green pen. You can use green color if you switch it at the top, but the green pen doesn't work.
Use green pen. This might not actually be drawn to scale kind of thing. Wait. Okay. Nice draw.
Hey, can we be supportive?
Yeah, good job.
No,
Well,
no, don't try to defend yourself. What you said was mean. You were being rude and a bully.
I wasn't being
Yeah, you were being a bully. Saying nice job when you're really being facetious about it. Like, that's mean. I know you're not, like, maliciously, you're not, like, calling names or anything, but that's mean.
As long as these
It's not a joke.
these two angles just have to add up to 180.
Perfect. Your generation needs to stop hiding behind the excuse, I was joking. You should go die in a hole. I was joking. It's not a joke, guys. I've literally heard your classmates tell each other to go die in a hole, and that's not a joke.
I literally just got told I was gonna be told this morning by someone and then passed out. It's just a joke.
Not cool, guys. I'm here to teach you more than just math. In a kite, the things that have to be satisfied are this leg and this leg. What? But congruent. So when he was adjusting his drawing, he was trying to make that happen. And then this leg and this leg are congruent. So then I can move points around to adjust these angles. These have to add up to 180. These have to add up to 180. And this is what we were working with the other day, dealing with all these triangles here. These similar triangles, top, top, bottom, bottom. But yeah, we can have a kite. So to answer the question, no, unless they added consecutive here. If the question doesn't have consecutive, then no, we can make kites. Those are not right trapezoids.
So is that what the lesson would be more about, like focusing on if they are incorrect, that like to adjust them?
Yeah, like so when we talk about definitions of polygons and what makes things what, we gotta really be analytical about definitions. Two right angles does not mean they're next to each other, but we were assuming that because what we had just been working with. So look at 7-7. So we talked about rectangles, comparing them with squares. So Carla decides to look at rectangles. She draws QRST, of course. After some exploration, she conjectures, remember what a conjecture is? That all rectangles are also parallelograms. Can we prove this? So we need to write a proof that in the end will prove all rectangles are parallelograms. How about it? You can go flow or two column.
I just want to curse her of thoughts because this guy's going to the rest of the line because she cursed herself. Get it?
Of course.
Curse.
No.
Your pronunciation be like the new word.
Where's
Alright. Okay.
I'm gonna draw this right thing.
What? That means increasing my angle from the line.
This is very valuable. That's not very valuable. I got it.
So you have this line, like you have this line, and then you have like this line. And then it's like tilted at a certain angle.
Because you need traces.
Tilt. As long as the tilt is
Ryan, traces. Traces right now. Ryan, traces right now. Or else you're going to the gold.
It can be anything as long as there's like a bunch of okay, so like very opposite slopes. So yeah, so for first no, that's just you actually did it. So it's not that. Any side is perpendicular to its adjacent sides and parallel to the opposite.
Rectangles must be parallelograms. What do we start with? Well, okay, but so are we gonna flow or two column?
Two columns.
Two column. Okay. Because so flow as opposed to two column. Flow would just say like all of these things because of this reason, whereas our two column would say all of these things because of this reason.
I like two columns.
And I don't know with CPM how they're gonna roll, but in my high school experience, two column proof was preferred. Like it's cleaner. So we have statement and reason. Statement and reason. So if we have QRST is a rectangle. What does that mean? Because that's given, but what does it mean that it is a rectangle? Like, what information does that immediately tell us, Ethan?
We've got 4 right angles.
4 right angles. So we could say angle Q equals angle R, and we would use congruent, but I'm going to go back and add those. Crap. Equals angle S equals angle T. Equals 90. And that's given, right? Or just definition of a rectangle. What else? Colin?
Given the fact that all of the angles are 90 degrees in these, this might be in the definition of rectangle. I don't have that available right now, but it means that all the sides are parallel to the opposite side and perpendicular to their adjacent sides.
So how do we define? So if we say like QT is parallel to RS, and so we got the left and right. So then QRTS. Why though? So the main part of our definition of rectangle is it's got 4 right angles. Right? Then we know that the sides are all equivalent lengths, but why? How do we know that those sides are parallel? And we just talked about this with that trapezoid, actually. We didn't formalize it, but we just we said that those 2 sides were parallel because
They are
not really a transversal because it doesn't go 3, but they use So we think about, don't draw this, but we think about this right angle and this right angle make these parallel, just like we had in the trapezoid. It doesn't matter what's going on out here. Why? Why do we know that has to be true? And even if this line wasn't straight and they weren't right angles, say we had something like that, I could still prove that these are parallel by comparing this angle and this angle. So, supplementary same side interior makes parallel lines. So our reason behind that would be supplementary, or you could change the order. You could say same side supplementary. Supplementary same side interior makes parallel lines. That's how we know they're parallel. We have supplementary pairs on the same side and interior. Doesn't even matter that they're right. It just matters that they're supplementary.
So because they're parallel, then the definition of parallelogram proves that they must be a parallelogram.
So now we have to formally state. What would our statement be? What are we trying to prove?
We're trying to prove that a rectangle must be a parallelogram.
Okay, but specifically here, what shape are we working with?
A rectangle.
What shape are we working with?
Oh, QRST.
Aha, QRST, because we didn't know that it was a rectangle, right?
Yeah.
We knew it was a quadrilateral. Now we're saying QRST is we didn't know that it was a parallelogram. We knew that it was a rectangle. Now we're saying QRST is a parallelogram. And what makes a parallelogram a parallelogram?
Two sets of parallel sides.
A
Yeah.
quadrilateral
Two
is
pairs.
a pair of parallel sides. It doesn't have to have at least one pair.
So the formal really we have outlined. We have opposite parallel sides. So we know it's a parallelogram now, right? Because of the stuff we've already laid out. Definition of parallelogram. You've already defined why it's a parallelogram. Now you're just pulling everything you've already done together, and because you already showed it up here, you can just, well, yeah, because that's what a parallelogram is. Does that make sense? Guys, we good? Make sense? Getting comfortable with defining your reasons is probably one of the hardest parts. Like, you guys can easily make the statements, but having formal reasoning of why, that's where people struggle. We're probably going to skip past this because that's just fill out the theorem graphic organizer and match everything else. So now we are going to dive into 712. Colin, can you do me a favor, bud? Could you try to minimize your pen clicks? Because it just like gets in my brain and throws me off. Like that, like just over and it just goofs with me, so I'm sorry. Like that's a me thing, but I just can't. It totally breaks my focus. So look at 23. Now, kind of fortunately, this is going to go back to what we did on Monday.
Ooh, I remember that. That was easy.
Missed the test.
Were you not here yesterday too?
Well,
Let's
not
make
here
your
for
test
2
up at some
days.
point. I've not looked at your test because I just got them
I
this
haven't
morning.
finished mine yet. I need to look over it still.
And depending on how many people need more time, I'll give you guys more time as a class. I just need to look at them.
I've missed it by one more time.
So, when we look at 23, we're looking at a rhombus, or plural, rhombi, no rhombuses.
Rhombus is
So, draw PQRST on your paper. Or not, sorry, PQRS, no T. PQRS. Doesn't have to be perfect, but you can trace it if you want. It's in your book.
tracing.
I believe I ran
Let's
trade
do
to
it.
second degree annoying.
Why are we going to mark the side lengths equal? It tells us then, draw a rhombus on, like the one at the right on your paper, and mark the side. Why? Why are we going to mark the side lengths equal?
Isn't that in the definition of a rhombus?
Okay, go on. So definition of a rhombus.
That has four congruent sides. A quadrilateral with four congruent sides.
Okay, quadrilateral with 4 congruent
I'm sorry,
sides.
square is also a rhombus.
So a square is also a rhombus, we said. So, if we jump down to C, we're being asked to make a proof. Audrey knows congruent triangles can help prove other properties about quadrilaterals. She starts by adding an auxiliary. What's an auxiliary line?
Percussion.
Segment or line added to a diagram.
A line
with
of
a
percussion
parallel.
instruments.
Yes, it is either your battery, your percussion instruments, or, if we're talking mathematically, it's an extra line that we're going to put in connecting things that is going to aid us in some way. So as Dr. Smith would always say, if you go to Otterbein, hopefully you have Dr. Smith, draw a line, any line, do something to help you in your diagram. So Audrey adds PR, public relations. So add PR. Sorry, try to make it straight. Prove that these are congruent triangles. Essentially, we're working our proof from the other day backwards. When we made a parallelogram with the triangle. So if you remember back to Monday, we took the triangle, we traced it, rotated it, put it on, proved that we had a parallelogram. Now we're extending that to prove that this is a rhombus made of congruent triangles. Question?
Do we even need to make this proof? It's pretty.
So what you need to do is show me that you know how to write the proof. So without my help, write the proof, defining statement and reason, or you can flow chart if you want. Statement, reason, getting us to those congruent triangles.
So we're trying to prove that PSR and the other side that they're congruent triangles. And
versa versa.
Yeah.
PR is convenient to PR.
We also know
What?
that PQ,
Oh.
PP, and so on and so on. Goes to each other. Becomes
PR
definite.
equals RP.
PR equals RP, Rick.
PR is convenient to PR.
If you want, you could give angle names. So you could say like A, B, C, D if you want. Or we can just name angles like S, R, P, P, R, Q, those different things. But if you want to make your life easier, give other angle names. Because you have your image for your proof.
Again, it would be
Two steps.
reference to actually have the
Side, side, side.
Well, I think that could work, but I think we probably when we need to explain that PR is congruent to itself and a reflective property, then do side side side.
You do if you're gonna use like if you're gonna relate three sides, you have to formally have given that information in the proof.
Okay, so PR.
So even when it's given information, we rewrite it and we put given in the reason.
Is congruent to PR. Rewrite PR to be equal to given. Now my side 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 is given.
I'm just gonna show you guys to save time. Yep.
I have a great joke. I'm
Oh,
pretty
no.
bad at this. Sorry, I said that wrong. I'm pretty bad at this. I guess you could say I'm out of shape. But I'm thinking of that. Wait, that was it. You used your time on? Yeah.
So, especially if you weren't in class, you could come reference our answers here.
Beautiful.
We are working on 23 right now. At the beginning here, so you can look here. Now the only issue that I'm having is on my browser. I can't really zoom. It like
It just
Schoology's weird with zooming. So I like if you guys end up with issues being able to see stuff, let me know. We'll work on that.
No, I got it.
But I think, because I heard people talking about how many steps, I think most of us are getting to the end of it. Day flowchart, right? So for us, if we did a 2-column, our statement and our reason,
PR is a diagram.
these three, all congruent pairs, the opposite sides congruent, and RS, or the auxiliary line, whichever way would be right from your vantage point. That's our statement. Actually, so we can only put 2 of those together. These 2 can go together. And then this one is actually reflexive. So we could give the reflexive first or give that second. Then, as I heard Jenny say, talking with Owen, we can use side, side, side. Right? Regardless, actually, of knowing, even if this is just a parallelogram, even if this would have 2 tick marks and that would have 2 tick marks, could we show side, side, side here? Yeah, because once RP is congruent to itself, it's got 3 sides. Question, answer?
Oh, I was about to say yeah.
Sorry, I was kind of asking that like,
rhetorically.
yeah, rhetorically. So 1, 2, itself, 1, 2, itself, we're good. And then they finish up their flowchart with CPCTC. This is how they put CPCTC, so please, I know it's hard to see from there, but they show congruent, like symbols, congruent symbol, triangle symbol, then the arrow saying make congruent parts. So yeah, I would rather just CPCTC because it's easier, but they draw the symbols. And then, chill, I just asked him to stop his pen clicking, now you're going to drum on your book. And alternate interior angles. So we could relate, if you did like me, we could say A to D and B to C based off those congruent parts of congruent triangles. That now proves my alternate interior angles. Questions on that proof? Flowchart is it's okay, but 2-column is better, more formal. All right, let's look at these 4 different shapes. The 4 polygons are rhombi. I did not think we were going to get this far today, so I do not have our don't have the printouts because I didn't think we were gonna get this far.
Square.
So you'll-
No, the one on the fifth one is the square.
Yeah, then
No. STRS.
So I think we can do this without resource page because I'm not gonna use the printer paper. I'm trying when possible. Draw a rhombus on your paper, and you could just as easily make it a square, but it will help your brain if you don't make it a square.
Okay.
Like a far one on the right. Left.
Yeah, so like if you make it like a stretched out, kind of more like a diamond looking rhombus. And we're gonna label this PQRS with a T in the middle. Now we just proved this is congruent to that. Right? We also knew that this was congruent to that. Similarly, what else can I do here?
Prove that
T is equal to the vertical from it because
So T is actually the intersection point. Be really careful with that. We can't use T as an angle name. But you are right, we have vertical angles here, vertical angle pairs. What about this angle?
congruent to angle TSR.
TSR.
RST as well. Alright. Well, that's exactly right.
Alright, we've got a lot of congruent angles. Okay, so let's mark some verticals.
I'm not dying.
Actually, everyone's
I know.
So there's 4 triangles.
So wait, when we had a kite, right, we had the top triangles and bottom triangles, these were congruent to. What do we have now? Take a moment. We got time.
4 triangles.
Okay, we got 4 triangles, we know that.
Or 2 triangles. Or 1 rhombus.
a quadrilateral.
Colin?
If you set, we have 2 pairs of congruent triangles rotated 180 degrees about 14.
So my almost like diagonal shapes are congruent to each other. So I take PQT, rotate it 180 degrees about T, I'm going to get another piece of my rhombus. I take QTR, rotate it 180 degrees, get another piece. How's this compared to a kite? What, like, could I take a rhombus apart and compare it to a kite? Chris?
Well, I could think about something different about it because the kite is already fluxed in with the rotation.
Okay, so kite does the reflection instead of the rotation. What if I took QRS? Flipped it.
This triangle.
I'm just trying to make you guys think about something.
Are you trying to
Same.
Just making you guys think about the triangles. that
What do
I
you mean by
made.
flip it?
So, like, if this triangle, yeah, reflect it over the line TS.
Oh,
Thank you.
just over TS.
So you,
So not. No, he means TS.
well, this line. I mean, yes, it's the same line, but this, only the bottom part.
of that line.
So then blue would come up here with the other blue.
Yeah.
Green would be with the other green. Purple would be across from the other purple.
Ah.
Just trying to get your brains kind of chugging away. So we have just a couple minutes left, and we're pretty much at the end of this. I'm not going to make you guys write out a proof for this. I don't think there's anything else we really
Big size of relief from 8th graders.
So we can skip this. Theorem graph organizer. So yeah, I know that some of you will be like, "What? Why?" Like, you want me to start this even though okay, so here's what's up. Some of these questions are really easy. What's the midpoint between 0.3 and 0.11? So realize we're getting beyond the middle of the year. Our review preview, a lot of these review problems are making sure that you can quickly
Get through.
remember the things we've already done. So these are skills that you should already have pretty, like, not all of them, but when you see questions like, really, we're being asked this, it's just making sure that you can quickly remember it. Check your answers as you go, or as you get the assignment done. But check the answers, make sure everything is good. If you struggle on something that you feel like you shouldn't struggle on, or if you just can't get something done, let's talk about it at the beginning of class. Okay? So, whole rest of the year, assume that once you leave my class, if it hasn't, like I thought about posting this earlier, the answers, but then I was like, well, if they're an AO, and then they just stumble upon it, then they don't know why it's there. But now, like that we've talked about this, I'll probably post these during my second block, my off block. So this will be up before you guys come to class. So as you get done with homework, just check. And it'll always be right here just on the updates page. So if you just go look by date, because we haven't really done much this year, I've thrown some random stuff up here. Did we talk about this, by the way?
No.
These guys got $3 million a piece.
What was the century code?
Minecraft.
Like, what was the
I
code
literally
itself?
put Minecraft down.
This was proving something about polynomial equations. So if you're curious about this, have a gander at that article. 3 million each. And there's your quadratic equation song, in case you need it.
Not now. Not now.
Alright, have a good day, guys.
How many
See you
questions
later.
are in CPM, like in our book?
In your book,
Yeah.
there are at least 10. 12. Sorry.
So we're over halfway done.
Yep.
Well, I need to confirm.
Alright, have a good day, guys.